The broadcast is now starting. All attendees are in listen-only mode.
Welcome to this ISC Safety Centre webinar on Delta HAZOP, getting more out of your assessments. My name is Trish Kerin and I'm the Director of the ISC Safety Centre. In today's webinar, I'll be joined by Paul Kenny, who's the Process Safety UK Technical Lead for ExxonMobil. This is because originally Paul had presented at our Hazards Conference in the UK about this concept of Delta HAZOP, and this project grew from that event. Before we start to talk in detail about Delta HAZOP, just a reminder that the Safety Centre is funded and supported by our members. Without our members, we couldn't do the work that we do, so I like to acknowledge and thank them for their support. We also have our range of industry partners that we work with as well. And a lot of these partners, both industry and operating partners, were involved in the development of this guidance document. We also do a lot of work with universities to make sure that we can help them develop and expand their process safety education so we get higher qualified engineers coming out at the end of their degrees. If we think about what process safety means, this is about a framework for process safety, this image on the screen. It's all about leadership, but that leadership is around a whole range of different aspects of the organisation. There's knowledge and competence, engineering and design, systems and procedures, assurance, human factors, and culture. Delta HAZOP sits within this engineering and design area. It's how we do our risk assessments. It's a new way to think about doing those assessments. So what is Delta HAZOP? Well, first of all, it's an alternative approach to some of the common assessment techniques that we've used in the past. It focuses on the changes that have happened since the last HAZOP, especially the subtle changes that can accumulate over time. And these may or may not have been picked up in management of change activities as well, because they are so subtle sometimes. It expands on the work that CCPS have previously done in their guidance on revalidation processes and methods that are currently used in industry. So we've looked at what was around, we've looked at what different organisations were doing, and we've brought it all together into this one singular guidance document. So where does Delta HAZOP actually sit in the scheme of all the different assessment methods that we have? This diagram shows you the idea that we have the concept initial stage, then we move to development, realisation, and the construction stage effectively, utilisation, this is the operational part of the facility, enhancement when we're doing sorts of improvements, and lastly retirement. This is the end of life activities that we might be doing. Delta HAZOP fits within this utilisation area. It's not about management of change type assessments. It's actually about assessing the current situation we've got with all the information flowing into it. And the reason that we use these terms of concept, development, realisation, utilisation, etc., is because they are some of the terms that are used in the standard documentation that describes guideword HAZOP, the typical process that we would have used previously. So we've actually made sure that when we developed our guidance document, we described it in such a way that it matched with the IEC guidance on HAZOP. And that's so that it's easy for you to follow and understand and see where the comparisons actually sit with this. We still go through the same concept of we have our definitions phase where we actually have to do the definition part of the activity first. Then we get into the preparation phase. We still have to do the preparation work that goes into building the information we need to do the assessment. Then we do our examination. That's where the actual assessment activity occurs. And then lastly, there's a documentation and follow-up. And these stages actually do follow what's in the IEC standard. In terms of the differences between guideword HAZOP and Delta HAZOP, so if we think about it, you know, the guideword, it's very structured. There's checklists to prompt scenarios, and we go through and view a node specifically. Delta HAZOP focuses more on the evidence and data of what has changed. And it views the system more holistically because it's not only focused narrowly at various points. I'm going to hand over to Paul now, who's going to talk you through some of the benefits of doing Delta HAZOP when we look at this risk discovery example and how we can actually uncover some interesting information. Over to you, Paul.
Thanks, Trish. So if you decide that Delta HAZOP is the technique for you, and we'll be talking later on about how to make that assessment. If you end up repeating the same study again and again, what you tend to find is a reduction in risk discovery, which shouldn't be altogether unsurprising. And certainly that's what we've found within ExxonMobil. And if you approach this from a different angle, as Trish has described, and you looked at the evidence and the data, you look for what's changed as well. Is it meeting its intent when you look at it more holistically? What you tend to find is that you discover a different risk profile. So, for example, what we tend to find when we conduct them at these points is that we discover fewer items than we would do if you go through the whole flow sheet as described in the AIC standard. But what you tend to find is more risk discovery per item raised. So it becomes a really good source of risk discovery when you're in your operation or utilization phase. One of the benefits as well is that we find that the assessments tend to take less time, typically around about half the time that a full guideboard HAZOP would take as well. So again, it's really a great advantage that we've found, because it ends up focusing your facility's limited efforts, limited resources on the efforts, and put them on where does it really matter, where are the risks coming from, and really get back down to where you'd like to be. Thanks, Trish.
Thanks, Paul. So there's certainly a lot of advantages to actually undertaking the Delta HAZOP. I'm about to now run through how do you know if the Delta HAZOP is the right assessment technique for you. Before I do that, I'd just like to remind everybody that if you've got any questions at all throughout this webinar, please put them into the questions box on your screen, and we will endeavour to get to them at the end of the presentation and answer them then. So if we want to look at, is a Delta HAZOP suitable? There's certain things you need to consider to determine if it is the right selection of risk assessment methodology for you. Has a utilisation HAZOP been performed? So do you have evidence of a HAZOP in that utilisation stage of your facility? Have all concerns from previous HAZOPs been resolved? And in particular, the higher level concerns, have they been dealt with adequately? Was the prior HAZOP team composition adequate? These are all sorts of questions around the quality of the last HAZOP that was done, because you do need quality input going into this. Were there any higher risk findings in the previous HAZOP, and what did you do with those? Some other items need to be, have there been any significant changes since the last HAZOP was done? Because obviously significant changes could very much change the outcome that you would be looking at from that previous utilisation HAZOP. Has the process safety information changed since the last HAZOP? Some of the data, the drawings, the set points, what sort of changes have occurred there? How healthy is your management of change process? Is it picking up all of the changes that have been made, or are you missing some? Are changes being undertaken in the field without going through the thorough management of change process? Has there been any significant process safety incidents or near misses since the last HAZOP was undertaken? Because they could represent some additional new learnings that need to be understood and assessed. Has there been any regulatory, government, company policy or company ownership changes since the last HAZOP? Because these changes might change your risk profile and your risk tolerance that you have in your facility. Have you modified your risk assessment methodology since the last HAZOP? Are you still assessing risk in the same way? Or fundamentally, have you changed in that as well? Has the facility determined whether the method meets the local regulatory requirements? So keep in mind, we're suggesting a methodology here that is not yet standard practice everywhere. You need to make sure your regulator is going to accept the results as you do it. Now, here's the challenge. This is an engineering judgment decision. There's no yes or no right answers to these questions to determine suitability. You need to ask yourself the questions, think about the answers, and then make an engineering judgment based on whether you think it might be the right process to undertake. If you think it is the right process, then you can check out the guidance document. It is coming soon. We actually haven't released it just yet, but it is coming out in the next week or so, hopefully. So you'll then be able to download it and see what's in there. We do go through the selection criteria of, is this the right choice for you first? Now, Once you get to that point, if you then do decide that it is the right choice and you are going to do a Delta HAZOP, how do you do it? Well, it is a systematic technique. It's using experience and data, though, rather than following a guide word process. It does have a checklist to focus the preparation and discussion to make sure you're getting the right information in, and that information is then being reviewed and analysed by the team. It is still a team activity. All the information needed for a HAZOP is required, but there's extra information you need as well. So Paul mentioned earlier, whilst it might take less time to undertake a Delta HAZOP, there's probably more preparation time that goes into it than a standard guide word HAZOP as well. So you've got to put the work in up front to make sure you've got all the data. So what sort of data do you need? There's some additional information. So I'm not going to run through all of the pieces of data that you need to do a standard HAZOP. That's the baseline assumption. But you need some additional stuff. Sorry, I've gone a bit. You need to have all of your MOC data in detail, the risk assessments associated with it, all those changes that have occurred. But you also need to make sure you understand the changes that are not covered by your MOC process. So you need to have a way to identify where things have changed so that you can take those into account. You need to understand the cumulative change impacts that occur. Even if all those changes have been done via an MOC, there will actually be cumulative impact that has occurred, because each MOC is typically conducted individually. You need to understand any staffing changes that have occurred, because that might lead to some of the information changing, or some of the way the system is being monitored and managed changing. Have there been any changes in the regulatory or company standards? You need that information to feed in. Other risk assessment reports that have been done, whether they are task-based risk assessments for certain elements of the plant, or whether they were other risk assessments that were done for other purposes. They might be QRAs, they could be any range of risk assessments in addition to the previous HAZOP report. And inspection and audit reports, because these are going to be identifying what's going on in terms of the overall plant and how it's functioning, and what you're finding as you compare it to your management system and how you're expecting your management system to operate. So once you've decided Delta HAZOP is right for you, and then you've decided you've got all the information you need, it's time to undertake the assessment. So there are a number of steps that we go through in terms of undertaking the assessment itself. We need to make sure that we provide an overview of the plant, detailing any changes that have taken place. And this is a discussion and a leading people through the process. Changes in the throughput, new equipment, any markups to the drawings, those sorts of things. We need to review the status of findings from the last HAZOP. Have the changes been incorporated? What actions are still outstanding? What are the consequences of those actions outstanding? And the ones that have been closed, have they been closed to show that everything has been done that needed to be done? Were they closed adequately? You need to review the list of MOCs, permanent and temporary. Are there any that stand out that you really need to drill into and focus on because they seem to be highlighting something that's going on? Reviewing the incident database for any applicable incidents or near misses that have occurred. This is really important because this will start to highlight to you what has actually been going on since the last risk assessment was done. What's changing? What's altering in your facility that you need to be aware of? Review any highlighted P&ID changes. So what has changed in the drawings that is reflective of what is occurring in the facility? In terms of undertaking the assessment as well, we now get on to reviewing the creeping or subtle changes. Now, there's a whole range of different things here that you need to review that might have subtle changes. The plot plans, any new material on the facility, any interlocks or safety instrumented systems, utilities, your inspection or testing practices, have they changed? Any regulatory issues, design standard changes, staffing changes, safe work practices that might have been altered or modified. Often our procedures don't necessarily go through a management of change process. They go through a separate review process. So the management of change won't necessarily pick them up. You need to pick it up in here. Detection and suppression systems. Are they still detecting, or are they detecting more frequently than they used to, perhaps, than they were designed to even? Hazardous area classification and what's going on there. And I've mentioned procedures as well. Once you've reviewed all of this information, then you're going to draft the report of the meeting and document any findings or areas of concern. These become your actions and the work that you do coming out of that particular assessment. And you need to then retain the HAZOP report as you would with any other report. So make sure that you maintain a copy of that report in your risk assessment management system so that you can go back and refer to it at any stage. Paul's now going to take you through a quick example that we did actually do, and this example is detailed within the guidance document as well. So over to you, Paul. Here's your P&ID to start with.
Okay, thanks, Trish. So this is just to give you a flavour of what you'll read in the guidance document, and it's really around how we execute the assessment when you've got your team there. And as Trish said earlier, and in the guidance document, there's an appendix which will take you through this. So what we got here as an example is a package unit which injects chlorine into a water system. We'll be focusing on node 4 in the blue, but there will be interaction with node 3 in the orange, which is the chlorine vapor system which gets injected into the water supply system. So previously we've determined that Delta HAZOP was the right technique for this plant. The objective of this plant is to reliably supply chlorine into the water system to adequately dose it. That's the focus of this facility, really. So the previous guide word will be HAZOP. We'll be going back and we'll be checking that. And I made some recommendations around no flow as well. So blocked venturis, which are used to inject the chlorine in. Valve failures, we do it, pump failures, and non-return valve failures. So firstly, in the appendix, what we do is we look back at the findings from this previous HAZOP. We check it out, and we see that actually all the recommendations were all completed satisfactorily. The issues that were raised, they look to be resolved on paper. We talked to the plant operators around preventing loss of flow. So happy enough with that, we can move on to the next bit. So then, next thing we do in Appendix B is we check through the management of changes. If you remember, Delta is around changes. What changes have occurred since that guide word HAZOP? So we noted that there was a recent plant problem with the non-return valve to the chlorinators, which is node 3, the orange one, failing closed. And so what the plant team have done is they've put a temporary workaround, which has just recently been installed a month or two ago. A hose has bypassed the non-return valve. And so if it trips, then there's a procedural response that the operators go out and they'll close a hand valve to stop water backflowing into the chlorine system, which was identified at the previous HAZOP as causing a potential issue as well. And we'll check that out as we go along. We've noted it. We'll check in more detail. Next thing we check is a review of the incident reports, the near miss reports. And actually, when we look through it, what we see is over the years, more and more frequently, the plant is actually shutting down. So clearly, given this is an objective of the study of the plant, why we conduct it in the first place, this is something that we'll be exploring in more detail as we go through, as our focus continues. We don't know the answer yet, but we'll look at it more frequently. There's a change here, and it appears to be important. So the next stage is we start looking at key plant data. We look at our process, our technical engineer who's in the study. They start trending some plant data. We start focusing on the trips, the plants shutting down. And interesting, when we home in some key parameters around it, what we see is a trend of when the flow decreases, the water flow decreases, we actually see a slight increase in the pressure of the chlorine flow system before the low flow alarms and the chlorine kick in. So actually there appears to be some sort of correlation going on here. We don't know it yet, but clearly this is an important thing. And we're going to continue on looking at other sets of data to try and understand what's going on here. So next, we use not just data, but we look at the experienced discipline engineers as well. We start talking to them about what's going on here. We home in further. We also check on our maintenance system, anything that could have happened around this area. And interesting, when we talk to that and to the discipline engineer. And what we actually found was several years ago, we made a change to the maintenance interval for the motors on the pumps. It used to be once per year we'd do a preventative maintenance routine. We now stepped it out to once in every 4 years as well. And this has bypassed the MOC system, which is why we didn't pick it up in the earlier MOCs. It's a subtle or creeping change. So in terms of the types of findings, we're talking now, so if you remember, there were two of these items we picked up. One was the bypassing of the northern return valve, and the second one was the increased frequency of plant trips due to the motor change. So if we just look at the first one, what we typically find here was the reverse flow potential, because the northern return valve was being bypassed, was identified in the previous HAZOP. It was cause 1, consequence 2. And if hand valve V340431 is not reopened post the chlorinator shutdown, then there's potential for a loss of disinfection going forward. If you don't reopen it post trip, the chlorine may not come forward when your water restarts, and you may lose your disinfection. That was already identified, and because we've now we're shutting this hand valve between the chlorinator injection and the water supply, the likelihood's gone up. It's not as low as it was last time, and the risk rank has gone up as well. So therefore, because the risk is higher, we've discovered that, we're going to raise a new recommendation. Our suggested wording would be a temporary MOC is in place, which bypasses this particular NRV. And so this safeguard, which was in the previous HAZOP, is temporarily ineffective. The HAZOP team now believes that a temporary procedure response is appropriate, however, recommends that an independent check is made on this hand valve, isolation valve V340431, as part of the system restart procedure to ensure an open flow path of chlorine. Thanks, Trish. And the second one, so if you remember about the increased frequency of trips of the plant due to the changes in the motor frequencies of testing. Again, low flow was identified in the previous HAZOP, cause 1, failure of the motive water pumps. But what we're seeing now from the plant data is that the likelihood is higher than what was previously assumed. So it's gone up one level. And as the likelihood's gone up, the risk rank's also increased as well. And as the risk's gone up, we're going to make a new recommendation. The HAZOP team believes that there is an increased frequency of loss of electrical power to these pumps, leading to low water flow. This leads to a high chlorinator vacuum flow and creating an increased number of plant shutdowns based upon plant near miss and shutdown activation data. It is recommended to improve the reliability of the MCCs by increasing the preventative maintenance testing frequency to reduce the number of plant shutdowns to once per year, which is what was previously assumed in the original HAZOP. Thanks, Trish.
Thanks, Paul. So you can see that we look at the information in a slightly different way, and then we focus in on what the key areas are that we need to really make sure we've got actions on to resolve the risk profile that we're seeing. So that's just a very short example, and the entire example, as I said, is included within the guidance document compared to what a standard guide word HAZOP looks like for the exact same node as well. So you can actually compare and see the difference there. So that was the technical detail that we wanted to take you through tonight. If you think this is the right process for you, then we have this guidance document, as I said, coming out soon. So it will be available for a free download on our publications page. It will be, as our other guidance documents are, they're all freely available for you to access and use as you see fit. In terms of who was involved in creating this document, it's important to acknowledge the people that were involved in it, not only because of the effort and work that they put into developing and refining this document, but also to show you the names of the organisations that actually back this sort of content and this sort of process. So you'll see that there's a large range of both operating companies as well as consultants that were involved in this particular project. Both Paul and I are now happy to take any questions that you may have. Paul, we've got one question in here first, and I'm actually going to ask it to you from your operating experience of having used the Delta HAZOP process yourselves and been in a company that is using it around various parts of the world. Can you please tell us what the major regulators, such as BSEE, OSHA or UK HSE, think of the Delta HAZOP process? Do you have any feedback on that?
Yeah, so our company's facilities in the US have been using Delta HAZOP for a couple of decades, I believe, and it's been accepted by OSHA as it comes under the banner, I think, of revalidation HAZOP, but it's one of the techniques which have been used there to meet the OSHA PSM requirement for a PHA study or a HAZOP. The HSE, obviously, it's relatively new in the UK. It doesn't have UK HSE don't prescribe what process hazards analyses to conduct, but initial conversations I've had with them is that they're very supportive of the focus on data, looking for changes, looking for hazards. It's likely to form something which is useful as part of your inventory or your armory of PHAs, which you can select. The key thing is making sure that you choose, as Trish, as you said, it's the right study at the right time for your plant. So in my experience, that there are no issues with the regulators. It really comes back to, as we said earlier in the checklist, picking the right study for the right time for your plant's objectives.
Thanks, Paul. The next question, how is this technique compared to others in the similar stage? So obviously we did show that there was a range of different risk assessments you would do within the utilisation phase of a facility. How do you think it compares? Are you able to give some thoughts on that?
There's a very wide range of PHAs out there, and some are experience-based and some are more structured and systematic based. And again, it comes back to choosing the right study for the right time for your plant, depending on what your objectives are. This is, for me, it's a nice blend of the experience-based and the guideboard HAZOP structure-based, because when your plant's been operating for some time, the likelihood is you've built up a lot of experience about how it actually runs, both with the local operations and also with your company as well. Typically, you embed this knowledge appropriately in your standards. And what it allows you to do is it blends that knowledge, and you end up targeting your efforts on where your risks actually are, rather than going through repeating, if you like, desk-based first principles techniques from the start, which you've probably already got covered, at least to some extent, from your earlier phase studies or perhaps your design-based studies. So it's a nice blend, I would say, in the middle. We find that the people who are in the study tend to be very motivated. They tend to be very engaged in it, because you're asking the people on the front line about what's really going on, and you're listening from them to then inform you where you go next, where are you likely to get risk discovery from the remainder of the study. So the team is really engaged, really committed, wants to give the answers. There's no quiet people in the studies, in my experience. And also, perhaps just as importantly, the output from these studies have been highly well received by the manufacturing organizations, because you're giving them a limited number of high value add items, which they can then go and they can execute, rather than a large number of perhaps somewhat theoretical items, which you can, I think I've heard some say, you have to sort of almost, wade your way through the sea of these. There have to be further work to actually determine which are the high value add ones, and which are the ones which, when you look a little bit harder, aren't really so much of an issue. So it enables a much more efficient way of getting ultimately changes in the field, which is what we all want from our facilities to make them safer.
Cool. Thanks, Paul. We've got lots of questions coming in now. They're coming in thick and fast. Okay, next one. Can or should Delta HAZOP replace regular guideword HAZOPs or be done in conjunction with them?
So you need to, it's in the guidance document, but you need to have done at least one full HAZOP, if you like. You've got to cover your plant. You've got to have that baseline before you can move off that. So, but once you've got that, as we talked earlier, you need to look at your plant, look at your objectives. Do you have a good MLC system? Are you controlling your changes well? We work through all that. But if you conclude at the end of that a Delta HAZOP is the right one at the right time for your facility, then you would just conduct it by itself to revalidate that previous full HAZOP, what's called a redo HAZOP. You wouldn't do two side by side. You would use the Delta HAZOP, if you like, to validate your previous conclusions, to give you a solid base that you're managing risks appropriately. Your conclusions from last HAZOP remain valid, or with some exceptions, you've got actions. And that would, if you like, fulfill your facility's requirements for a PHA at that time.
Okay. Now, the next question is, how will Delta HAZOP differ majorly from PHA revalidations or cyclic guideword HAZOPs? I guess my thoughts on that would be that the Delta HAZOP clearly does not have, it's not a guideword-based HAZOP activity, so it actually, the checklist that we provide more focuses you in on exploring different areas rather than the standard guidewords. Would you agree with that, Paul?
Yeah, absolutely. And what you hinted at in your presentation, the focus tends to be on the changes, particularly the subtle changes or the creeping changes, because as you and Suzanne have talked about in other IChemE sessions, creeping change is a major source of major incidents. And what the guidance document, what we've learned is that if you explore those in a little bit more detail, those are the things that unfortunately have often caught out industry for major process safety and reliability events. And this technique will hopefully stop some of those from occurring and ultimately add a lot of value for your facility as well.
Yep. The next question, neither of us may actually be able to answer. Has this technique been used in the UK nuclear industry, where regulators are still non-prescriptive, but operating companies are long extant with conservative approach to new methodologies? This method seems appropriate to supplement MOC, where a plant is a long-running and may have creep in scope, for example, of waste, etc. I can't speak to whether it has been used in the UK nuclear industry. Obviously, we did state that you need to make sure that your regulator is accepting of the process and make sure that it's going to be an adequate process for you. Having said that, you may find value in doing the process to understand the risk, and then potentially where there is a regulated method that you must follow, you may then choose to follow the regulated method at that point. It's around what value you're going to get. And I think you'll get a lot of value out of this sort of process in terms of really trying to understand those creeping or cumulative changes that occur in a facility. You agree with that one?
Yeah, absolutely. And my personal opinion is that we're paid professional process safety engineers, and our job is to make these judgments about what is the right thing to be doing for my facility at this time. And no one knows better than us what the hazards are, the risks are, the regulatory environment as well. So it's about engaging your internal stakeholders and the external ones, such as the regulator, and just having an open conversation about that and going, well, I've got these techniques out here. I think the right one this time could be is, for example, Delta HAZOP.
Yep.
This is how we're going to be doing it. And are we all aligned? It's the right study to do it at this time. And just have that conversation, really.
Mm-hmm. Okay. How does this process compare with the ExxonMobil knowledge-based HAZOP?
So it's as I say, it's a revalidation. So you've got to have a base to start from. You've got, if you like, cover your whole plant, line by line, equipment by equipment, node by node. Whatever technique you use to do that, be it guideword or knowledge base, is you've got to have that as the base. Then Delta HAZOP is really the several years down the line, typically, when your facility goes, well, what's my PHA I should be doing now to revalidate that previous study. And it's one of the things in the mix. So you can redo a guideword HAZOP, you can redo a knowledge-based HAZOP, or you can do a procedure-based HAZOP, a transient operations HAZOP, or you can do a Delta HAZOP. It just goes into the mix. So it's a revalidation technique fundamentally, though, looking at what my last HAZOP, say my redo, on what's changed, and is it the right technique to do at this time.
Okay, cool. Someone's commented the methodology appears similar to what Shell refers to as a process safety review or a technical safety review, which is done on a 5-yearly frequency as a mandatory part of the corporate process safety requirements. And that methodology has also been accepted by the Queensland Major Hazard Facility Regulator. And I think one of the things that we found when we undertook this process was a lot of different companies saying, oh yes, we have a similar sort of process. So what we ended up doing was looking collectively at the processes that everybody had and really pulling out all the great things to produce the guidance document. So there will certainly be similarities in other organisations' processes that they have. This is a way to sort of formalise it a little bit more in a public space, I think. The next question, Paul, is there a particular example of a key risk that you have identified using this process that you're able to share with us?
Yes, so if you remember, Trish in the intro said I presented this at ISC HAZOP. This is back in 2018. So I shared one there in my paper. I'm not sure if people can find it. It's gone into the ISC's loss prevention bulletin and also the chemical engineer magazines a year or two ago. But the one that really struck out for us when we first tried it was we have a facility with atmospheric safety valves on some fractionation towers. What we found was that the number of demands on the independent safety critical high level alarm on these towers was increasing over the last several years from when we previously assessed it. And when we followed the data around and we looked at some things, so we looked at external incidents. After we all know the Texas City incident in 2005 of overfill. So that was an external incident. Let's learn from that. We looked at the data. We saw the number of P1 alarms increasing. We looked at the near missing incident history. Again, we saw the number of notifications for these activations going off. We saw the number of plant shutdowns or squats, as we call them, increasing over the years because of some unreliability in our utility supply system. And when we looked at that in a bit more detail, we looked at the plant data. Well, what's going on here? Why are these alarms going off? We find that when we were doing startups post these shutdowns, we found that the operators were struggling to control the level in these towers quite often because of the way they're left post a utility failure. And when we looked at more detail, we actually got uncomfortable because the number of demands, the opportunities for overfill were increasing from what we assumed from our, if you like, a desk-based review several years ago. And the data, when we plugged the actual shutdowns, what was happening then, showed that the risk had gone up by, let's call it an order of magnitude. It was from an acceptable one to one where we're not happy. And so we then kicked off a project to install independent level height cutouts on SIL1 projects on these towers as well to help mitigate the risk going forward. So that's hopefully was it with a has to say a great example. We shouldn't have been there, but it was the following the data, asking the operators targeted questions about what's going on at startup, really discovered it. And when we discovered it, we brought it on the table in the right way for the site management. We were able to put in appropriate short and long-term mitigation projects, which if we hadn't been looking so close at data, we might not have always found this.
Thanks, Paul. Good example. In your experience in doing Delta HAZOPs, has there been a situation where experience shows the initial design was overly conservative and there was a recommendation to reduce safeguarding at all?
I've not come across that because it's not said you can't do that, but the starting point from Delta HAZOP is you need to align it with what your facility's risk reduction objectives are in the first place. And typically, in my experience, they're around preventing the low frequency, high consequence, the catastrophic type of failure events. And so because that's our objective, we spend our time really homing in on those scenarios, looking, are we doing absolutely everything that we can and should be doing? And so that's really the effort. And that's where we've got the risk reduction value, which has been well thanked and well appreciated by our our facilities.
Mm-hmm.
If I guess theoretically, if you had a different objective, which involved looking at over design, if that's what you thought was a potential benefit for your facility, I'm sure the technique, if you follow that way through, could probably give some insight as well. But that would be I think unusual as an objective, at least in my experience.
Okay, thank you. How do you demonstrate that the Delta HAZOP has thoroughly covered everything?
Well, the appendix B, I think, goes through it in a quite a structured manner. The thing to note is that you're not just, I talked earlier about it being a nice blend of experience, focusing on real problems. But actually, it's remember, what you're really doing is you're springboarding off a full unit HAZOP, at least one, if not two, if you decide when it's the right time. And so you're getting the benefit of these HAZOP teams, these HAZOP studies, which have been happening in the past, and you're really paying your respect to them, because they have covered absolutely everything on the plant from this technique's scope limitations. And all you're really doing is you're saying, I've got all this fully covered. I'm going to go and check to make sure there's some key assumptions around areas that really matter to the plant. I'm going to check to make sure that they really are still covered, and that the people who were in these reviews in the past, that their conclusions are still valid, ultimately, that we still respect them. And we're just going to go and look, has the plant subtly crept, perhaps through accumulation of changes, into a different regime that they wouldn't have been comfortable or happy with as well. So it's to be remembered, it's not just a one-off technique in an isolation. You're really building upon the structure and covering everything in previous HAZOPs as well.
Okay, thank you. What's the typical team composition for a Delta HAZOP, Paul?
It's the same one as for a redo HAZOP. There's no difference. What we would say, though, as in the guidance document, is recognizing that you're trying to find out changes. You've got the data, which you'll be using, but a lot of it comes from people having been there and seen it and done it as well, to highlight through the structured questioning when things may have changed. So actually, although the team composition may remain the same, you typically would prefer people who have a bit more experience, or at least people who have been there since the last HAZOP, and then can talk through, well, what was it like then? What's it like now? Has anything changed?
Mm-hmm. Cool. We've still got more questions to go. Is there an average amount of data needed to do this sort of risk assessment? Is there any way you can sort of quantify that in your experience?
Well, the guidance document calls out pretty well the data which is needed, and it's no different to any of the data that you would need for a redo HAZOP, but you need a little bit extra because you're going to focus on the changes. So you'll need to pull on your list of management of change logs, for instance. What we tend to find is that the preparation time is a normal HAZOP plus a bit extra, 10%, 20%. It really depends upon how easy it is to recall the data which has been stored in your facility. If most of your stuff's gone online, then the time to pull it in becomes incremental. If your data is stored in disparate databases, perhaps hand-cut, clearly it's going to take a bit more time to get it.
Mm. Yeah, and that then sort of flows into the next question, which is, is the Delta HAZOP shorter than the normal HAZOP? And as you've just said, the preparation time is a little bit longer, but the actual workshop time is shorter typically, because you're not doing, guide word assessment on each node as such. You're doing more of a holistic view of the changes.
Yeah, absolutely. We tend to, so I was just going to say, we tend to find the execution time is maybe broad numbers a half the length of time needed for a full redo HAZOP in round numbers.
Mm-hmm. Yep, good. Another comment here, so great presentation. Can it be used to demonstrate risk reduction to a LARP or SFARP? What do you think?
Absolutely. So, yeah, so you're typically going to have, well, you should already have your scenarios identified for major hazards or whatever, for example, from your previous HAZOP. And ultimately, from that studies, you'll have taken them to a point where you think your risk is as low as reasonably practicable, or so far as reasonably practicable, ALARP, or SIF ALARP. The challenge being is that as your facility, runs on, changes, matures, people move jobs, etc., the normal life of an operating plant, how do you know that in practice the risk really is where you thought it was at ALARP? And as I said, when you look at the history of major incidents, a lot of them they've been where the facility has subtly crept into a different place, and the risk really wasn't ALARP, I guess is what you would say. But with the data in front of people might have, and presented in the right way, people may have made a different decision for some of these incidents and may have intervened in a different way. So it gives some reassurance to your facilities owners, to your risk managers, that the plant which is out there running today is actually ALARP. And if not, then it should give you some really high quality targeted recommendations to pick out the highest risk stuff, which gives them a chance to intervene before a near miss or something even more serious occurs.
Mm-hmm. Okay, thank you. I've got a comment here. One suggestion of another area to look at as a source of risk is to assess the boundaries of the MOC HAZOPs that have been undertaken. And absolutely, we talk about a range of different pieces of data that need to go into this process, and it really is looking at all of that information that went into the MOC. But I do like the idea there of the boundaries of the HAZOPs that were done in the MOC. Were those boundaries in the right spot? There have been instances of events or incidents that have occurred where, because of where the boundaries have been drawn, potentially something wasn't fully understood further outside the scope that was focused in on with the management of change activity. Another question here, what sources would you recommend reviewing to ensure you've fully captured creeping changes which have not been captured via MOC? That's a good question. How do you know what you don't know?
Yeah, I covered this in my presentation. It's a famous quote on that from Donald Rumsfeld, and it's the unknown unknowns, and they're pretty difficult to pick up with any assessment. But the reality is that with a mature facility where we understand how it runs, we understand the technology that have been built up. The reality is, for most issues, I would hope for them all, but we can never say never. We will know how the plants should be running, and if we pay a little bit of closer attention to the data which matters from our experience, we'll know the things that matter more to run our facilities correctly. We will tend to find, if we look closer, when things don't actually look right, when things are not going per the original design intent, things are not going per the assumptions in the previous redo HAZOP. And so actually, a Delta HAZOP is in some ways, it's a way of moving these, I think they're called the unknown unknowns. Someone knows something's not right, but for whatever reason, the organization isn't acting on them appropriately. Is to move them in the organization's consciousness into being known knowns. And once they're there, the organization is typically very good at acting upon it when it's got a real risk, well defined, and it knows what good should look like. It makes it very easy for the facility to really act upon it and drive risk down to where it should be. It should be alert.
Okay. Thank you very much for that, Paul. And unfortunately, my screen has just gone a little bit crazy there, so we'll just go back to that holding screen. Thank you very much for that, for taking those questions and taking the time to go through them. We hope you enjoyed this presentation. As I said, the guidance document will be coming out in the next couple of weeks. It'll be available on our website. We're also working on a short training package to take you through how to actually do a Delta HAZOP, so how to be the leader of it and really understand what that looks like. We have another webinar coming up in October, so if you're interested in dust explosions, then please check out our website and you can register for our upcoming webinars. That's all we have for you for today. Thank you again, Paul, for your time. Really appreciate not only your guidance in leading the project for us, but also in presenting this webinar.
Pleasure. Thanks for having me, Trish.
All right. Thank you, everybody, and please stay safe.